Hi, everyone. This is a recording of my summary for Unit 2. So what I'm going to do is run through a couple of key concepts and then go through what are the two sort of big models in Unit 2. The first one being, how do we figure out which technology a firm will choose? And the second one being the Malthusian model. So first concept I just wanted to highlight is the idea of an equilibrium. So what we mean by an equilibrium, a situation that is self-perpetuating, so that something of interest does not change unless an outside or external force for change is introduced. So it sounds a bit complex, but what we mean in economics by an equilibrium is when we have an outcome or an allocation where we think things won't change, right? So if you think about a demand and supply model, we know that we're going to get an equilibrium quantity and an equilibrium price where demand is equal to supply. And if nothing changes, that price and that quantity will stay the same. We need some outside, some external force, something to influence demand or supply in order to then move to a different equilibrium. So that's what we mean by an equilibrium, when we need some external force to kind of alter the place where we're at right now. Second key idea is the idea of a model. So economics is really all about building models. And what do we mean by that? Well, it's a really broad definition. And it's when we start off by thinking about some decision, some situation that economic agents face. And what we try and do is kind of strip back lots of the complexity and just think about really simple things that kind of represent the conditions that people face when they're making that decision. We then look at what's going to determine the actions that people take, what factors do we think are important or most important. And then very importantly, we think about how people's actions will affect other people, how one agent's actions might affect someone else's. This will be particularly relevant when we think about game theory. And then number 4, we then use our description of all of this to try and figure out what we think the outcome will be. And quite a lot in economics, we think that's going to lead to some sort of equilibrium where, if it's a game where the players would choose a particular set of actions and wouldn't want to change their mind from that. In some of the situations we're going to see later on in this video, where there's a particular technology chosen and the firm wouldn't want to change their mind. And the main reason we build these models is then to think about, well, what will happen if things change? And so we'll see later on, the technology that the firm chooses will change when some external thing happens, like when wages change or the price of coal changes. So that's kind of the purpose of building a model. And quite often in economics, those models are written down in the form of equations, which tell us what choices people will make and what those choices depend on. So the next key idea is the idea of ceteris paribus. And this just means we are thinking of everything as being kept constant or other things being equal. And this is quite a useful idea when we want to analyze the effect of some sort of change. So again, in the context of later on, we're going to have a firm that chooses a particular technology. And then what we're going to do is think, well, how might that decision change if the wages of the workers change? And we use ceteris paribus thinking because when we say the wages of the workers change, we assume everything else that's important to the firm's decision stays exactly the same. The price of coal stays exactly the same. The technologies available stay the same. And we then analyze what will happen to the decision of the firm if just that one thing changes, and we assume nothing else changes. And that's really, really useful concept in economics. It helps us figure out or think about how a particular factor might have an impact on the outcome of our model. All right, a really key idea here, and again in economics in general, is the idea of relative prices. That there's a nice example here. So if you're deciding where you want to shop, if we're comparing a corner shop and a supermarket, what is most important to us is what are the prices in the corner shop relative to the supermarket? Like, are they more expensive? Are they cheaper? And that's what we mean by a relative price, prices of one thing compared to another. Now, we might also be interested in the absolute prices. So like, for example, if the prices in the corner shop and the supermarket both went up by 5%, then overall, we might decide to buy less wherever we go. But in terms of deciding which one to go to, that's probably not going to have an influence, right? Probably not. It could, but probably not. What's going to be more important is the price of one place relative to another. And we'll see relative prices playing a very important role in the first model that we're going to look at shortly. So I think final couple of key concepts. Economic rent. So what do we mean by that? Well, what we're doing is comparing the benefit you would get from choosing a particular option, the option you have decided on, and then subtracting the benefit you get from your next best option. And the economic rent is the difference between those two things. Now, if that's a positive number, you've obviously chosen the best thing. And because it's a positive number, you have an incentive to choose that thing. Now, if this ends up being negative for some reason, then obviously the next best option wasn't the next best, it was the best one. And you could benefit from changing your mind. So in economic rent is just a way that we have in economics of trying to figure out, is there an incentive for someone to switch their choice, to change their decision? And we have a special name for the next best option. We call it the reservation option. So like the thing that you'd go to if for some reason your first choice can't be taken anymore. Okay, I think, yeah, that brings us then to our first model. And our first model is this setup where we've got a firm who want to make cloth, and they have 5 different technology options for making the cloth. So A, B, C, D, and E. And what we mean by technology options is different ways of producing the same level of output. So technology A, for example, they need 1 worker and 6 tons of coal, and that will give them, say, 100 kilos of cloth. Technology B uses 4 workers, 2 tons of coal, but it'll also produce 100 kilos of cloth. So whichever option of these 5 technologies they choose, they get the same level of output, but you can see that they require different numbers of workers and different amounts of coal. So how does the firm decide which technology to choose, which one's best? Now, before I go into that, just some terms to point out. Here we could talk about labor-intensive technologies and maybe energy coal-intensive technologies. And what we mean by that, so say by labor-intensive, is a technology which uses a high amount of labor relative to the amount of coal. So technology E would be a good example of a labor-intensive technology because 10 workers for every 1 ton of coal. In terms of energy-intensive, we might look at option A, so 6 tons of coal relative to every 1 worker, right? So how do they make the choice? Well, the first thing they might do is just rule out technologies which we could say are strictly dominated, as in ones that just really don't make sense. So C, for example, doesn't make sense, right? Why not? Because C requires 3 workers and 7 tons of coal, whereas A requires fewer workers, only 1, and fewer tons of coal. So there's seems to be no reason why you would choose option C, right? When you could achieve the same output with fewer workers and fewer tons of coal. Another one that's completely ruled out that is strictly dominated would be technology D for the same sort of reason. Right? If we compare D to B, D uses 5 workers, B uses 4. D uses 5 tons of coal, B uses 2. So B strictly dominates D. You know, it's better, it uses fewer inputs to get the same level of output. So that's one way we can start to rule out some choices. But that leaves us with A, B, and E, and we can't kind of pick one over the other without thinking about something further, which is cost, right? Why can't we rule them out? Well, because if we look at A, 1 worker and 6 tons of coal, and B, so more workers, but fewer tons of coal, I can't say which one right now is kind of better, lower cost than the other one. So in order to do that, we need to add a second ingredient to our model. And that second ingredient is the idea of Isocost lines. So Where do these come from? Well, a kind of like simple bit of our model really, which is if I write down an equation to represent my total cost, the total cost of the firm. So total cost, let's call it capital C. And we've only got two inputs, the number of workers and the tons of coal. So my total cost is going to be equal to the price of workers, or the wage, which I'll call W, multiplied by the number of workers, which I'll call capital L, plus the price of coal, which I'll call P, multiplied by the number of tons of coal, which I'll call capital R. Now, if I do a little bit of rearranging, then I'll be able to show that this can give me an equation of a straight line on this graph. So what I'm going to do is rearrange this to make R the subject. And what I'm going to get is that R is equal to minus W over P times L plus capital C, the total cost, over P. And we can see that the minus W over P, that represents the slope of one of these lines. And the C over P represents the y-intercept. So this is the equation of what we call an isocost line. And what we mean by isocost is that if I pick one particular line, every combination of coal and workers that's on this line will cost the same amount, right? So this one, you can see the cost is £80. So in the equation here, C would be 80, and there's a particular value of W and P where every possible combination of R and L will add up to £80. Now here, we are assuming that the wage, W, is equal to 10, and that the price of coal is equal to 20, right? And so we've got four different lines here. They all come from just choosing different levels of total cost, right? So this one's 40, this one's 80, this one's 120, this is 150. But notice one very important thing. They all have the same slope, right? And why is that? Because the equation of every line, the slope of every line is determined by W, the wage, over P, the price, right? The price of labor relative to the price of coal. So all of these lines have to have the same slope, okay? So this is a really important ingredient, because with this, firms are now going to be able to decide which of those three technologies to choose. Because if we assume they want to choose the technology that is the lowest cost, which seems reasonable because that'll help them maybe increase their profits, then what we think about is we have a whole map of these isocost lines, and the technology to choose will be the technology that is on the lowest possible isocost line. And so this line J to H here, this is the isocost line that kind of is represented by the equation that I wrote before. And we can see that an isocost line with this particular slope would, the lowest possible one would be where we have technology B. So that tells us technology B, given this particular wage and this particular price of coal, is the cheapest one that this firm could choose, right? And so they have an incentive to choose that one because it's going to give them the biggest possible economic rent. Now, one thing I could do is kind of think about, well, like, how do I definitely know this? Well, think about if we have a line with the same slope, and the slope has to stay the same here because the prices are the price of wage, the price of labor, and the price of coal haven't changed. So if I need a line with this slope that goes through, say, technology E, right, then I can see that that line is further away from the origin. It's higher up. It's a higher total cost. And to get to A, I'd have to go even further away, an even higher total cost. So technology B is definitely the best one to choose because it is on the isocost line, which is closest to the origin, the lowest down, which means it's got the lowest total cost. So that's what this model is all about. It's about how could a firm decide which technology to choose? And we see they choose the one that's on the lowest possible isocost line. So now let's think about a change, right? So we still got technology A, B, and E, but now we're going to think about things changing. And in particular, we are going to imagine that now the wage is still 10, okay? So that hasn't changed, but now the price of coal has fallen and fallen down to 5. So if we again think about the equation of these isocost lines, remember it's minus W over P times L plus C over P. And so a change to the price is going to have an effect on the slope. It'll also affect the y-intercept, but most importantly for us, it's going to change the slope. And you can see, if we now draw out isocost lines with this new slope, you can see that they are much steeper, right? So this solid red one and this solid gray one, they represent the new isocost lines. So the old isocost line, technology B was the best choice, right? Now, on the new isocost lines, if we want to choose technology B, it is actually cheaper than before, right? It's gone from being 80 pounds to 50 pounds. That seems really good. But technology A now lies on a lower isocost line, one that's closer to the origin. And in fact, choosing technology A only costs 40 pounds. So again, if we assume this firm is like behaving rationally, they would now switch from technology B to technology A. And again, we could think because there is an economic rent available, right? The benefit of choosing technology A is a lower cost by 10 pounds than if they chose technology B. And a kind of maybe like final point on this, the lines have become steeper and now they're choosing technology A. Well, technology A is one that uses quite a lot of coal, not many workers. And if we think about the change that's happened, this kind of makes perfect sense because workers still cost the same, but coal is now much cheaper and relative to workers, it's much, much cheaper. And so switching from a technology which uses 4 workers to one that only uses 1 and uses more coal, that seems to make sense. And that's kind of backed up by what the model is showing us what would happen, that the firm would switch to technology A. So that's the first model in Unit 2. Shows us how a firm can, once they know the different technologies, and they can construct isocost lines by knowing the prices of the inputs, then we know they choose their technology by the technology which is on the lowest possible isocost line. So the second model in Unit 2 is the Malthusian model. And the Malthusian model relies on 2 big ideas. The first is the idea of diminishing average product. And this graph right here shows us precisely this concept in action. So first really important thing, the kind of purple line here represents a production function. Okay, and a production function is something which tells us if I have this many inputs, this is how much output that I'll get. And what we're looking at here is we want to produce an output, which is grain, and our input is farmers. And now something the graph doesn't show, and we kind of assume, and it's something that Malthus kind of assumed, is that there is also another input, which is land. But one thing Malthus did was to assume that the quantity of land is fixed. Okay, so we got a fixed amount of land, but we can change the number of farmers. And this kind of production function, you can see a concave production function, where as we kind of go further to the right, the line, the slope of the line is getting shallower and shallower. This is going to lead to both diminishing average product and diminishing marginal product. But here, the diminishing average product is the important thing. And we can actually see just by a couple of calculations that this is the case. So if we look at point A, where 500,000 tons of grain are being produced, or sorry, 500,000 kilograms of grain are being produced, and that's being done by 800 farmers, So the average product of labor, the average amount of grain produced per farmer, is that 500,000 divided by 800, and we see it's 625 kilograms of grain per farmer. But if we go up, higher up to point B, where now we've doubled the number of farmers, we're now getting 732,000 kilograms of grain. So if we work out what's the average product per farmer, the average amount of grain per farmer, we do 732,000 over 1,600, and we see it's 458 kilograms of grain per farmer. So this is supposed to show us that if we have a fixed amount of land and we add more and more farmers to it, yes, the output will increase, but as we get to higher and higher numbers of farmers, that extra bit of output every farmer is getting smaller and smaller and smaller. So this is a key part of Malthus's explanation of why living standards would never in the long run rise. And the second part of his explanation is he said that if living standards did start to rise, that would cause people to then have more children. It would cause the population to increase. And the consequence of these two things, of higher living standards, meaning higher population, and diminishing average product of labor, the consequence is that we would always return to a subsistence level of wages. And so that actually in the long run, living standards would never actually rise. Maybe in the short run they could go up, but then that would lead to higher population, which would then bring living standards back down. And the way that Malthus's model can kind of show this is through the use of two graphs here. So the one on the left shows us the relationship between the real wage in the economy, and that gives us an indication of living standards, and population levels. So we kind of see when when population goes higher, the real wage falls. And Malthus's explanation for that is that higher population means we've got a lower average product of labor, and a lower average product of labor will translate into lower wages for the workers. So higher population means lower wages. And the link with the right-hand side here is to show us the sort of second part of Malthus's model, which is when wages, say, go up, population growth could become positive. When wages fall, population growth becomes negative, right? So higher wages, higher living standards encourages higher population, right? Encourages population growth, and lower wages would encourage population decrease. So let's use this to analyze what would happen under a particular change, right? The change you can see here with a move from this blue relationship between wage and population to this purple one. Now, the first thing we need to do is identify our starting point. So if we're in a Malthusian equilibrium, we must be at the subsistence level of wages, and the subsistence level of wages is defined by the level of wage that leads to a constant population. Okay, that's really key. Subsistence level of wages is where we have a constant population, which means population growth is 0. So that's why A prime here gives us our starting point, and it shows us that this must be where the real wages are in an equilibrium. And so if we go across to our blue line to begin with, that's going to then tell us at this level of wages, we'll have this population median. So that's our initial equilibrium. And now we get a shock, a change, an external force, which is going to shake us out of that equilibrium. And this change is the introduction of some new technology. And this new technology is going to increase the average product of labor. So at every population level, the wage is now going to be higher because people are now more productive. So we can see this sort of shift to the right or this shift upwards. But what we need to keep in mind now is the wage level is still going to be at this subsistence level, right? It's still going to be here, wage low. But wage low at when we've got this new this new kind of relationship, wage low is going to lead to, hold on, let me pause for a second just so I can think about this. Okay, I'm back. Just thought that through for a second and can make more sense of it now. So what we have is we've got this new relationship between wage and population. But now that this change has happened, we still are at this median population, right? That hasn't changed. Nothing's happened to the level of the population yet. But this population level with this new technology is going to earn a higher wage high. But what does this mean? Well, if we now have this new high wage and we go across to the impact that's going to have on population growth, we see this new higher wage would actually lead to a rising population, an increase in population, right? Second part of Malthus' model, higher wages, higher living standards leads to an increase in population. So what that's going to mean is now population is going to move from median population over towards this higher level of population. But as that happens, the average product of labor starts to decrease. And so the wage is going to start to fall. And that's what this arrow is showing us. We're moving kind of diagonally down because we're getting a higher population, but a lower wage. And so the population will keep on increasing until the wage goes back to our subsistence level, all right? Because at this subsistence level, then we're back to zero population growth, okay? And then there's no incentive for anyone to have like more children. And so we're back to our subsistence wage level, this low wage level, but now at a higher level, a higher population. And this kind of shows us like a key part of Malthus' idea, which is that the population of the world could increase, right? And that technological improvements could help that to happen, but that living standards would never change, because as living standards in the short run get higher, that will cause people to have more children, which then, due to diminishing average product of labor, will then start to cause wages to fall back towards that subsistence level. So population gets bigger, but the living standards, the wage level in the long run will never get higher than that subsistence level. But we can actually use Malthus' model to show us how the subsistence wage level could change. And you did see this in the homework, which is if there is some change to people's kind of decisions about like having children. So for example, in the homework, we saw that everybody decides now to, at particular wages, to kind of like have fewer children, right? Something that slows the birth rate, for example. And if we kind of go through the analysis here, we'll see that like our new equilibrium is going to have to be determined. Our new subsistence wage level is going to have to be where our new population growth curve has zero population growth, right? It's going to have to be at this wage level. So if we have a change in kind of people's preferences about like birth rates, we could actually have a higher subsistence wage, right? It doesn't always have to go back to this, say, low level. If something changes about the population growth curve, we can get a change in the subsistence level of wages. So maybe the final thing to say is, well, how do we get out of this Malthusian trap? Well, one way you've seen is here, where we get, you know, this change in people's preferences towards birth. But kind of another way we could think about it is if the improvements in technology are happening at a faster rate at which the population is growing, then we could get two things happening at the same time: higher population and higher wages. So increasing population and increasing living standards. And that's a key idea of the Industrial Revolution, that it was the beginning of this permanent technological revolution, which led to improvements in technology, improvements in productivity at a faster pace than the population was growing. And that's how we escaped the Malthusian trap. Okay, so that's, I think, the key things in Unit 2, some key concepts and the 2 key models. So I will finish up there and I'll see you again in the Unit 3 video.